In this question, we have to find a vector of length 1 that is parallel to the line given by these two equations, y minus z equals 1 and 2x minus y plus z equals 2. So what does this look like? I think the best way to approach this problem is to think about, what does this look like? Now, this is actually two planes. So when we have this linear system, it's describing a plane, and this one is also describing a plane. And these planes are intersecting, and we're trying to find a vector that is parallel to the line of intersection. So I've taken the liberty of drawing what this plane looks like. Oops. It looks like this here. So this plane here, the bottom one, that's the green plane, and this orangish plane, that's the top one here. And so the vector that we're trying to find that's parallel is actually parallel to this line here. We're trying to find a vector that's parallel to that line of intersection. So how can we figure this out? Well, if these planes intersect, then the line's perpendicular to plane. So if we have a perpendicular line coming from this plane and a perpendicular line coming from this plane, so the normals of those two lines, I'll draw those in a different color here. So the normals of these two planes, then those intersect as well. That just has to happen. And so the best way, I think, of looking at this is, as I've taken from another perspective here, is that if we did take these perpendicular lines, let's just get this pen here. Okay, so we take a perpendicular line, the normal of this plane, and the normal of this plane, and what can we do with that to find a vector that's parallel to this intersection here? Well, if we took the cross product, remember the cross product is we have a vector here, another vector here, it'll return a vector perpendicular to both. So what happens is when we take the cross product is we end up getting a vector that's exactly perpendicular to both of the perpendicular lines. So we have a vector that's normal to the normals, which ends up being parallel to the line of intersection. So we have to go back up, and the calculation after this is pretty simple. We just take the normal of this equation, and so there's no x, so it's 0, 1, negative 1. That's our normal. And then we have, for this equation, we have 2, 1, 1. So now we just have to take the cross product of these two vectors. So we'll go 0, 1, negative 1. And I'm going to cross that with 2, 1, 1. And so in another video, I showed how to do the cross product. So if you don't know how to do that, you might want to check out that other video. So I'll just go ahead and calculate this. So we have 1 times 1 minus the negative, so that's plus 1 times 1. And we go negative 2 minus 0, 0 minus 2. So there's our cross product. So that's going to give us our vector that's perpendicular to both those lines. So we have 1 times 1 plus 1 times 1, so we end up with 2, negative 2, negative 2. So that is our vector that is parallel. So the other condition of the question was to find a vector of length 1 that's parallel to both of those lines. So we know that the length is equal to each component squared. So we go 2 squared plus 2 squared plus 2 squared. Of course, the negatives will cancel. And that is going to be equal to our length. Now, since the length has to equal 1, we can just write this as x, because it's going to have to be times some scalar, because we're going to have to take a scalar times this vector here to give us a vector that's length is equal to 1. So we go x times the square root of 2 squared plus 2 squared plus 2 squared, and that has to equal the length of 1. And we're trying to solve for x to see what we're going to have to times it by. X is going to be our scalar value. So the next step is we can just simplify this equation here. And so 2 squared plus 2 squared, so that's 4 plus 4 plus 4, and that's just going to be 12. So x times the square root of 12 is going to be equal to 1. So this means that the square root of 12 is equal to 1 divided by x. So we just divide x and we divide x from both sides. So this means that if we take the inverse of this equation, we'd go 1 over the square root of 12 is equal to x. So now we know that if our scalar value just has to be 1 over root 12. And so to get the vector, length equal to 1, we just times it by 1 over root 12. So our vector is going to be 2, negative 2, negative 2, divided by root 12 equals the parallel vector. Now we can also simplify this. You know, we could make the root 12 is also equal to, let's see, we could do 2 times root 3, and if the 2's cancel, I mean, this is basically the same as writing, if we just divide each one of these components here by 2, we'd end up getting 1, negative 1, negative 1, divided by square root 3. We could also write it as this, or we could just write it as this. So again, all we just did was we took the normals, the perpendicular equations to each line, and then we took the cross product of that, and that is going to give us a vector that's parallel to the line of intersection. And then after that, we just took the cross product and we simplify it, and to get it to our right length, all we had to do was solve for x.